all flowers in full bloom. You are given 0 index array. Flowers, okay. Flowers, and the flowers is a start. Means that ice part will full bloom from start and inclusive. And you also give the persons of the size. Person is a time. Ice persons will arrive to see the flowers. Okay, so 2, 3, 7, 11. Fully put. So basically we say we figure out that this will be 1, this will be 2, this will be 2, this will be 2. Oh, just the range segment. So we say idea is line sweep. Okay, we know the flowers. We know the flowers like map is going to be sorted array to do that. Okay, so the timeline, and we say for each flower, the time will add 1. Time minus 1. Okay. So now what is the idea? Suppose we have some time traverse, and you need to something we need to do is going to be time and the value that it is. Okay, so value, so means the time is traverse and the numbers of the flower. Okay, for each time value, time, we know the flow. Okay, flow will add about the value, and basically we say 1, time traverse of 1, we will going to be values will push back. So we need the start time and the flow here. Okay, so something we need to do is pair, and the pair is sorted. Okay, and for each person, I just try to do for each person. Let's just try to binary search the first value, because okay, we can just try to do that. Yeah. Okay, now let's just see. Okay, I want to use this data structure such that we can easy to binary search the value. Okay. Okay. Persons. Okay. So if we just binary search about time, okay, so binary search about time is going to be the values lower bound, because the person P, if IT is going to be values, and we will say 0, or the IT is the greater than we just upper bound previous upper bound because we need to search that the first person. For example, say 2, we search about the 3, and the previous value is going to be 2. Yeah. Basically 2, we will search that the upper bound will be 9, and the replace value will be 3. Okay, so if means we don't have anything, the flower is going to be okay. That is the idea. Okay, wait. Oh, auto flower. Add 1. Okay, this is not a pair, so you will not do that. Okay. Suppose we have the idea. Okay, very easy problem. Okay. 2D integers of rectangles indicate that each rectangle have a length and a height. Okay, it's the length and height. You also give it 2D points coordinate. Okay, coordinate means that each rectangle's bottom left corner point at. Oh, I got the idea. So each rectangle has the bottom left corner point at 0, 0, and the top right corner point at the length and the height. Okay, so we have length and height. Okay, now what I want to do is we want to calculate the numbers of a rectangle that is contained about the query, right? So 2 and 1 is going to be this, and the first rectangle contains no. Only second rectangle contains only 1. The third rectangle contains about 1, 4, 1, 4, and this. Okay. Okay. So what is the idea? Suppose let's just think what is the constraint. I want to know that. Okay. So calculate the number of rectangle that cover points. Okay, for each point. Okay, we need to return this resource. And basically I want to know the length. Okay. Length is pretty big. Okay. So the constraint is going to be we cannot brute force approach to see the points, numbers of points. Okay. Okay, so for each rectangle, I just try to calculate the number of the smaller value. Okay, because the value is all. So this constraint, the both position of the points is greater than 0. So we say we just calculate numbers of the smaller value. So yeah, how to do that? Okay, that's just a 2-point approach, but need to think about this. Okay, what's the idea? Okay, all points and rectangle is unique. This is a second constraint, right? Because yeah, if this is not unique, actually it doesn't matter, but unique, that means that we only calculate once. Okay, so for this rectangle, we just calculate how many number that is smaller than 2 and how many number that is smaller than the height. Okay, so suppose we sort array of a point. Okay, or suppose we just 2, 1, we just we sort array, we sort rectangles. Okay, we sort rectangles based on the x value and y value. After that, we just binary search about the x value. We calculate the numbers of the smaller value that is going to be. So we have 5. Okay. And we also have the 2, right? So suppose we just try to do is, we know this is 2 and 1, so length must be greater than the 2. We need to calculate. So we can just first sort, okay, sort the rectangle, then sort by default value, and for each point try to binary search the first coordinate. Okay, we binary search the length, because length is the x, right? So we binary search the length. Try to binary search the length. Okay. Okay. Now we also know that range between this. Okay. Wait. Height and the edge is 100. So, okay, since the constraint of the y3 that is more, binary search the length. Okay, suppose we know the length of this query is here, and we just calculate the numbers of the value that is greater than. Okay, let's think. Basically we say for 1, so means we just calculate the numbers of a value that's smaller than 0 is 0. Okay, so for this range, we know the prefix sum of a 0 is 0. We don't need to do that. So I have some idea is because, okay, since the y is small, so we can use prefix sum to do that. Okay, prefix sum to do that. So let's just try to do that. Use prefix sum to store y. Okay, and for each coordinate we just binary search then, and we know our left, right. Okay, we know the left position here, and we just calculate the suffix between this. Okay. Okay, suppose we have. Now let's just record prefix sum. Okay, for each coordinate, we just sorted the rectangle. After we sort rectangle, let's just build prefix sum. Okay, now we build prefix sum. For example, for this, we just try to build prefix sum is going to be very simple. Just we need to know the length. Okay, need to know the length. That is rectangle size. Still have prefix sum. Prefix sum. The first dimension is this, and the second dimension will be length of +1. Okay. Okay. Now how to do that? Let's try to do for is going to be 0. Okay, for each y is going to be 1, right? So y is going to be 1 and y is more than 100. Just calculate this, okay? Constraint of the xy is small. We can do that, okay? Suppose we have done a prefix. We just try to record answers. Okay, x is going to be p0, y is going to be p1. And I just binary search the lower bound of the rectangle. We search x and y. Let's think about this. Okay, y. Okay, we just search point. Now we know the index between and for okay, we still need a value. Value will add about the prefix on so far. Okay, and I forgot to use an in. Prefix first dimension is k. The second dimension will be this. I want to do T1, and this will be okay. Okay, that's idea. So now let's just build prefix. Okay, build prefix is equal to y. Add about rectangles. I1 is equal to y or not. This is equal to y. We will say rectangle begin, rectangle end. Rectangles begin, rectangles end, rectangles. Okay. So that's idea. Wait, forgot to push back. Okay. One and 4. Oh, wait. Suppose from this position we are trying to do. Okay. Wow, a math problem again. What the fuck is for this contest? Okay. So you have the circles here. Represent the centers. Where this number of the lattice point. What is the lattice point? Lattice point is the integral coordinate. And okay. So you know the circle is going to be 2 and 2 and 1. You want to calculate the lattice point. Okay, I want to know the constraint. Oh, circle may be a array. And basically we say the coordinate of the array is going to be and the inside is exactly 1. So because the rectangle x, the constraint will always be positive, right? So we can just try to use them, because for coordinate and the radius is 100, so the maxima of a range. So idea is enumerate all points, and we just calculate if this is in circle or not. Okay, is in circle or not. Okay, so suppose we have rectangle here. This is circle, and we also have the point of the x and y here. Okay, point x and y here. How do we check is in circle? So we just calculate a radius here. We just calculate that this distance. Okay. So the distance is going to be circle minus about x power of 2 add about power circle minus about y 2, and this should be smaller than r, and we can say return that the distance is smaller than circles. Okay, this is circle. Circles 2, because radius means the distance r per r is a add about b. This is the formula of the circle. Yeah. Okay, so now let's just try to do x is going to be 0. How many lattice point is this? Okay. So if it's going to be say quarter circles is in circle, we will say count add 1 break. We don't need to do circle is decline here. Wait a moment, just try to think about this. Okay, oh wait, this is circle. Let's find 16. Okay, just the idea. Okay, intersection of a multi-array non-empty distinct positive, that is percent sorting ascending order, 3 and 4. Oh, so idea is just use set and to intersect the value. Okay, order value numbers. Okay, set is going to be numbers 0. Okay, so we have the next set. This is the array and the value. Use set, and for each number, just put into set. Okay. So we say the array here, if the set will count about this value, that means we have the intersection here. Okay. Okay, set move. Return that directory. Okay. Okay. 3 and 4 and empty. So that's the idea. Okay. Okay, finish this contest. Wow, so fast. Of this person. Just interesting. Okay. Too fast. Okay, good. Okay. Now let's just go search each problem. So this problem, the problem is say that there are intersection of array, and you also need to sort them in the ascending order. For example 1, you see that okay, 3 and 4 are present in the each array. You see that, okay. So let's just use a set, and for each array, we just put the intersection. So basically, we put about the first array, and then we just put the second array, and we don't consider a duplicate because you use set, right? And we also doesn't consider first numbers. Yeah, that's it. And the time complexity will be n log n, actually, yeah. Wait, it's not n log n, it's the numbers length, and numbers i's length. Okay. And question number 2. This problem is very boring problem. It's just you just calculate if this is in circle or not, and because the constraint of the points is very small, it's 100, so we can enumerate all points, and we just check that okay, if this is in circle, we just add this. And how do we get that the maximum of the lower bound and upper bound? You can see radius, because the radius we can add the middle point, add about the radius. If the middle point is 0 and the radius is going to be 100, we set 100. But the middle point is going to be 100 and the radius is going to be 100. So we have the 200. So we enumerate from 0 to 200 to make sure that we cover all points. And in circle is very simple formula. You can just Google or Google it. Yeah. And then question number 3. Okay, this point is very not interesting, but you need to, okay, it's just the problem is that, so you give a lot of rectangles and you need to calculate for each point, you give a point and you need to calculate the numbers of a rectangle that is contained about the j's point. So for example, let's say this points, how many numbers of a rectangle that is cover the point? We said blue and the purple, right? Blue and purple. And 1, 4, we only have 1. So what is the idea? Idea is that if we search, if we sort the rectangles, we will get sorted array, right? And after we sort the array, we just enumerate the range. And since the constraint is more, y is 100, so we can build a prefix sum. We build a prefix sum that is going to be equal to the numbers of a rectangle. Okay, so overall time complexity will be 100 and times about the length of array and the points of array times this. Okay, so why we use lower bound? Because we binary search the point of the p, and if we know the p, for example the 2, 1, we binary search about this. Okay, so we see what is the first rectangle that can be greater than greater or equal to 0.21 is 2, 3, and we just calculate this range. How many y is covered? So we just from y to 100, because the maximum is 100, we just calculate the prefix sum. And this is the idea. Okay, this is the idea. I think there is another approach, but because the constraint is smaller, so we can use this approach to do that. Okay, you can use this approach to do that. And the question number 4, this problem is very classic, or it says a very simple, relatively simple hard problem. So give it, you can see the diagram or graph, picture. You see that you want to know for each person, you want to know how many flowers in this range. Okay, in this time step. So we see little person will see 1, and this person will see 2, this person will see 2, this person. So the answer will be 1, 2, 2, 2. And how to do that? So we can use the lines sweep approach, and we just add the first and minus the last, and we will get time. Okay, and after that we just use a map to record the count. For each time segment, just record the count, because the time will be unique, so we don't care about this. Okay, after that we just binary search. Okay, how to binary search? Suppose we have, you see the time step in this. Okay, for example 1, we know this is 1, 3, 1, 3, and 1, 3, the 9, 4 and 9, 4 and 9, the start position, and end position will be 6, 7, the 12 and 13. Okay, suppose a person will be 2, 3, 7, 11. We just try to use the upper bound approach. How to do that? Suppose we know this range, right? We know these flowers in this time state. Okay, we know the flowers in this time state, and we just binary search. Okay, 2. We binary search the upper bound was 3, and we're starting from this because this range is 1 to 3 is equal to x. Okay, suppose this is 0, that's 1. Okay, so 1 to 3 is going to be 0, and 3 to 4 is going to be x1. So that's the idea. So we just use the upper bound and use private, and we can easily know that the x0, because yeah. And if this is begin, let's just see, you need to care for that. If this is person 1, and we know, okay, we don't have previous iterators, so we just push 0 to the answers. Okay, yeah. So this is today's contest. Okay, just like this. Okay.